Today we have Riley Smith with us, and he's going to be talking to us about automation and lumber grading and packaging. Riley is the sales manager of TS Manufacturing in Lindsay, Ontario. He's been with the company for almost 24 years. TS Manufacturing has been in business since 1973, serving the lumber industry and several other industries. Just last year, they acquired automation and electronics out of New Zealand. Before we begin, I will ask that everyone turn their speakers on to mute. We'll have time at the end of Riley's presentation to ask questions. So at this time, I'll turn the meeting over to Riley.
Good morning. Thank you, Bob and Linda. 24 years. My father was joking me that I'm almost too old to be participating in NextGen stuff. So when I started, I think going to the HMA, I used to had to, oh, I shouldn't say this, but when I first started going to trade shows, I had to lie about my age at restaurants and things of that nature so that I, didn't get ID'd because I didn't even have ID. So nothing more awkward than being in a fancy business dinner at like Morton's and somebody asking, if you're allowed to have a glass of wine or not. Not that I was drinking them, but, it kind of changes the topic. So Bob and Linda asked me to talk about this and specifically about automation and grading and packaging. And I apologize. I keep looking down at my screen and I've got a camera up here. And once again, I apologize for all the mistakes I'm going to make at the start. And just bear with me, guys, and we'll try and get through this. Trying to make sure everything that I have that can pop up stops popping up. So I'm going to share my screen here and try and present my PowerPoint. Hopefully it works. So can everybody see my screen now? Okay. So, well, I already clicked one too many times, sorry. So, and you can see the whole slide because I've got the little window over top of it. Or you guys see a little block area where the screen is? Maybe that's better. So as Bob and Linda said, automation and hardwood grading and lumber packaging. And I apologize if I get too detailed or make any grading mistakes or anything of that nature during this presentation. As Bob highlighted, I'm a machinery sales guy, not a grader, but I know a little bit about grading from what you guys have been gracious enough to teach me through meetings and mistakes that I've made with customers over the years. So, and from John Seifert's very short course, introductory grading short course that he gave me. So, anyways, so I'm going to go into detail when we're talking about grading. Basically, we typically see grading before the trimmer or after the trimmer, end grading or grading from the center. I'm going to try and give you some breakdown on the different ways, and I'm sure everybody is familiar with it, but trying to set a baseline that I make sure that I explain everything. So basically, if you're grading before the trimmer, typically we'll see 3 people, the grader, the trimmer operator, and then the person you don't see at the back end is typically the tally person who's either tallying the packs or not. One of the things that we found over the last 6 or 7 years is that most people like to automate their tally and for sorting and things of that nature, and you don't have to have a bin sorter to do this. We call that a virtual bin sorter when we're sorting on a pull chain, but it allows you to get production data and things of that nature. And when you automate the grading, and by automate, I'm going as basic as putting the grade information into a control system so that you can track it, measure it, record it, and report on it, as well as trim loss and things of that nature. So basically, if you're grading before the trimmer, we can take that all the way back down to just having a grader and not need a tally person or a trimmer operator, depending on the operation. In most existing mills, you'll have to relocate your trimmer in order to facilitate putting your grader in front of them. Um, that's not always the case. If your grader operates as also a lug loader operator, you can grade the board from the end and fit it in a similar footprint or the same footprint as what your trimmer is in now. But typically when people are looking at this, there's production concerns that require additional space anyways to get the production through. So there's what I'd call the standard hardwood sawmill grading, and I think we're going to focus more on the dry package makeup and things of that nature, but I'm going to kind of switch between green and dry here just because these are the photos I have, and I apologize that most of them are TS photos, but that's what I have photos of, so that's what I'm able to present. So in this case, you can see you got a grader walking the deck, flipping the stick. He's got a crayon for marking the grade on the board, and we have a trimmer operator who's board dealing and hand shifting the boards, or cants in this photo's case, into the trimmer to make the trim decision that the grader specified. The tally person would be after the packs in this example, obviously. So, and this is the only example of grading behind the trimmer that I could find with a video or photo of a grader behind a trimmer. So as you can see here, we've actually got 4 people. We've got a 2-saw trimmer operator, a lug loader, and the grader back in the background. So, you know, there's a lot of opportunity to, I don't like to say eliminate headcount, but not have to hire their replacements when they either move up or find other positions based on our labor challenges our industry seems to have these days. So as I said, there's often 3 people: grader, trimmer operator, and tally person. If you're grading behind the trimmer, you will always still need a trimmer operator and a grader. You don't have to typically relocate the trimmer because it already exists, and you can grade from the center or from the end after the trimmer. So, and like I said, I'm going very baseline on this, so I apologize if everybody finds this boring, but I often get asked questions about how grade mark readers work, less and less as time goes on. But so typically when you're automating grading, you can either have a grade mark reader or a console for basic automation. So your grade mark reader, a lot of graders really like it. It's intuitive. They're writing on a board. They can move with the board depending on the setup. They know what they put for the mark on the board. Different colors allow you to separate which grader did which grade, so it allows you to do some verification on graders. There's some features that make it really good for trim back on untrimmed sawmill lumber in particular. But it is awful on a dry line if you're not that anybody in this video would do it, but I've heard rumors of people that will try and mix grades, particularly when overseas markets are strong. The one person that I'm thinking of, I don't know their name obviously, but tried to push the amount of 2 common they could put into a 1 common pack. That works if you're using a console. It's not so good when your customer gets a pack with 10 boards with a different grade mark on them from the rest of them. So the only other issue is you can't really do grade mark reader if you're grading from the center of the board or if you're walking the chains, because grade mark reader is typically at the end and your mark isn't accurate enough if you're writing on it with a stick. So here's a picture and example. One of the things that people wonder is how you can get the information on a grade mark reader. So on the left side, we have an example of where all of the marks are, and you don't typically need to make all of those marks, but you can see that what I find to be one of the most easy aspects of the grade mark reader is the near end trim or fence trim. So you just draw a straight line across the bottom of the board, as you can see near the lumber line, and that then becomes the fence amount, and it's accurate to about 1/8 of an inch. So it's really quick, really easy if you want to cut off a near end defect, and then you can put the grade above it and let everything else work. But if you want to do cut and two or 2-grade solution. You can then put a length for the first grade zone. You can put a grade for the far end grade. You can do cut and middle. You can do all of these things, change species, off species marks. You don't typically have the time to do all of them on one board, but technically you can do it. And that problem exists for a console as well as for a grade mark reader, but the big advantage that graders like on the grade mark reader is they don't feel like they pressed the wrong button and don't know what it is. So like if you have a console and you press a button and the board passes, you don't necessarily know what button you pressed unless you print on the board or do something of that nature. And at that point, it's already too late. It's been sorted and trimmed and it's gone. Whereas at least you'll see often graders when they mark a board and they mismark the board, they'll flip the board over and put a different mark on it. So the other nice thing about grade mark readers is it does handle very high speeds with multiple graders. So it's just a little video of a line we built that actually is running purchased lumber and sawmill lumber together, 2 separate grade mark readers running, I think up to, I think here it's about 15 boards a minute per grader, but could be up to 25. So the nice thing is that the grader, you can see each grader tends to grade at a different point. So whereas a console, you have to grade when the board is in the grade zone. Otherwise, you're assigning a grade to a different board. So console. So similar to the grade mark reader, we have to handle grade, fence, cut and two, trim backs. If it's in front of the trimmer, if it's behind the trimmer, you just really have to assign it a grade or a remand decision if you want to send it back. You don't mark the board, so it works really well for finished product. If you're trying to mix grades or ensure that you've got some kind of custom grading algorithm that you're sending your customers, you don't end up getting any issues or any claims as a result of the marks on the board. It is limited to where you're doing the marking, and it also tends to be a little more limited on the near end trim. Some of that can be handled on grading from the center, or what I call off-lug grading, where the grader gets all the time that they want to look at the board. So, typically you have, if you're grading in a lug, you have to grade for the duration of the time that board is in front of you, or you get behind or looking at the wrong board. If you got a turner, it gets in your way. If if it takes too long, basically you don't see both sides of the board, you have to return boards. Whereas with a console, if that board leaves the zone that the console's for, it has to have had a grade, or you can apply a default grade while you're running. But so you can't typically do an infinite fence adjustment on the near end. You can if you have overhead lasers, but in that case, it's greater speed. You can't force a speed like you can on a lug system. So it's got its benefits and its negatives. There's probably no perfect system, sort of like difference between grading from the center and grading from the end, species, markets, production requirements. Basically, what you're used to doing tends to have as much of an effect on how you're going to go. So basically, if you're grading from the center, console is your only option, unless you go with a voice input, which tends to be a little slower and has more issues because it's got to repeat everything you say to it back to you as you're grading. So I've got some poor examples of consoles here, and I apologize. These are all consoles that we have done over the years. The nice one is actually down on the bottom right, but I found that I didn't have any nice photos of it. So some of these buttons are a little out of alignment in some of these photos, and that's actually why the photos were taken, is for QC. But you can see in the top left that we have a grading console for after the grader. This is installed, or after the trimmer, sorry. It's installed behind a trimmer in Wisconsin, and the grader is grading from the center, and they pick a grade, and they're numerical because basically, depending on the species, each grade represents a different species or a different grade depending on custom grades. There's no trim back allowance, and the board is measured after the fact. So they have some simple operational buttons and then 15 grade buttons. The one on the right is in front of a trimmer. It's running a single console grading system with a single waterfall grading station. So you can see that we have far end trim increments in 1 foot increments, near end trim increments in 1 foot increments, and fence increments in 4-inch increments. So if you want to make an adjustment that's less than 4 inches, you really don't have a choice in this example. So depending on your overlengths and things of that nature, that's where I find consoles typically have challenges. The flip side of that is you never really can can fence more accurately than you can measure. So I have a customer that, for instance, has photo eyes every foot. So they're going to know how long the board is to the 1 foot increment, and it's in a sawmill. So often in a sawmill, you'll get those overlength boards. So you could get a 10'9" board that you trim 6 inches off. And if you tell it to fence 6 inches, bad example in this console, he's only got 8. So let's say he trims 8 inches off. That system isn't going to know that it's still going to make a 10-foot board. And so in that case, a lot of systems will actually drop that down to a 9-footer. So you've just taken a 10'9" board and turned it into a 9'1" or 9'2" board so that you could take 8 inches off the near end. So, all of these various ways of, grade input and length measurement and width measurement and thickness measurement all has an effect on what system's right for your application. In a sawmill, you may want more thickness measurement because you've got a lot more wane typically to deal with at the trimmer. In a dry line, a single point thickness measurement is typically sufficient because the board's already been cleaned up usually. So I talked about end grading and center grading. So center grading, typically the graders all move at their own pace. We've got customers that tell us that results in an upgrade of 4% or a 4% average uplift in grade values. So that means that if 10% of the lumber was FAS, it shifts to 14% and basically does the same shift all the way from 2 common up effectively. So just because they're given more time to look at the board and move at their own pace, they don't risk getting the claim board. So, I don't think anybody's ever claimed a pack of lumber for getting an FAS board in a 1 common pack. So, if you think it could, it definitely makes 1 common, but it might make a higher grade and you don't have time to think about it, often people will take that difficult board and shift it down a grade, whereas when you give them enough time to make the decision, you get that grade uplift. So the other thing is you can sit in the center, and this matters for, depending on species, if you've got really hard to find defects. I've got video of walnut running from end grading, and I have video of walnut running from center grading. So I kind of typically say that the difference between center grading and end grading is a little bit of a religion in most cases. And I don't try and convince people one way or the other, because whatever works for you is part of your product and how you sell your finished lumber to your customers. So our job, we see, is to typically work to understand what you guys need to ensure you get the piece rate, automation, and typically headcount savings that you need to be competitive and effective in the market. So you can do infinite fencing from the center pretty easily with an overhead moving lasers. I have a quick clip that shows one of those coming up. The downside of grading from the center is it's typically slower piece rate. It's pretty common to get an average of about 11 boards a minute at the top end. I've seen as high as 15, but the other downside of having multiple grading stations is typically the footprint gets much larger and the cost gets much greater very quickly. So one of the challenges we get is if somebody needs to do a certain piece count and it's borderline over a single grader's capacity from the center, you get more than a doubling of cost because you have to split the flow and then rejoin the flow before you feed it back together. So, so here's some examples of what we call center or waterfall grading. All of these, the grader is able to move at their own pace, and you can see that the boards deal after they've made a decision. So if they can make a decision quickly, they can move at speeds up to, I think, 25 pieces a minute. But basically, they get the time they want per piece to take the decision and make the decision. So some of these are just simple measuring systems. Some of them have behind them, some of them have optimizers, and that changes a little bit as to what data you get. This video here has, you can see some moving lasers. If you look close at the right side, you can see that they've got an overhead laser for when they input a trim decision. So they'll see where it's actually going to trim the board, and the lasers move relative to a fence decision. Sorry. So then we get to end grading, which is probably 75% of the grading projects that we get asked to look at these days. Used to be that there seemed to be a dividing line somewhere around Virginia, where you would, maybe Kentucky, Virginia, in that north-south region, where everybody north of it wanted to grade from the center and everybody south of it wanted to grade from the end. But it's starting to shift that I think production requirements for a lot of people have gone up, and end grading tends to allow you to have multiple graders more cost effectively while still saving some head count. So, you know, you can do end grading, can be lugged or unlugged. You don't have to have any kind of station at all. If you use a grade mark grader, you don't need like some kind of zone that the grader has to stand in. They can literally walk from the unscrambler all the way up to just before the grade mark grader. You can do what we call above lug stations, where you can have multiple stations above a lug chain, which basically divides the flow. If you have two stations and you're running 40 lugs a minute, each grader is doing 20 lugs a minute. If you're doing 3 and you're doing 60 lugs a minute, each one's doing 20. Or if you're running 3 and 45, each one's doing 15. You can easily turn, typically only a single turn on an end grading station, just because of the zone, unless you have a hook style station. The biggest thing that most of our customers find on end grading is by setting the lug speeds, they can kind of force a production rate. So I've had customers even test not displaying a higher lug rate and cranking the lug speed up. So I think one person set it so there was only 17 boards a minute to the grader, and their grades were on target, and they cranked the speed up, I think up to 22 from there. And they found that they lost grade above 17 boards a minute green per grader. But we're going to talk a little bit about optimizations, grader assist capability, and most of our systems don't have an optimizer. Trimmer optimizers in hardwood are, I'd say, typically people have a carriage and an edger optimizer before they even think about a trimmer optimizer. The first one I was involved in was 16 years ago. And the customer said, I was there with John Seifert, and customer said, well, John, it's the last thing we have to optimize. And the last 2 projects we did were so good, we just needed to optimize our trimmer. And, you know, that's typically what we find, is that people who have a trimmer optimizer already have an edger optimizer and a carriage optimizer, and they've seen the value and control that it gives them. So, but it also, in many cases, reduces the challenge for a grader. So here's a quick clip of some different end grading systems. So this one is a grading in front of the trimmer with speed up chains, and the video doesn't show it, but the only person running the line is the grader. There's nobody between the unscrambler and the pull chain other than the grader. So he's marking the board with a grade mark crayon. We're trying to stay out of the way while videoing it. There's a sloped one with above lug grading stations that has some ability to move and cue back and forth. So that's why there's 3 cue hooks on it. The customer wanted to be able to get that extra board, and actually if they walk to the end of the station, the whole lug chain slows down to give them more time. with a pressure pad underneath, so that basically the grader can intuitively focus on grading the board and the line will respond to what they need. So multiple graders grading from the end on speed up chains, and you can see there at the end that the one grader regraded the other guy's board. Sloped with shark fins. That's running a dry line in North Carolina. So it's got a tilt hoist lug loader operator and a grader on it. This line's in Georgia and basically has a tilt hoist and a lug loader and 4 graders, even though 3 are only pictured in this video. So, you know, you can push the speed a little more. And then this is another line here in Pennsylvania that's doesn't have any kind of grader assist other than it's got a long lug chain that he can walk with the board. So once again here, unscrambler to the pull chain, the only guy is the grader. Another line with above lug grading, there's a bunch of different zones or different styles of above lug grading systems that we make, and basically it allows you to see the graders operating. Now, if you watch, the guy at the front was in charge of the console to solve the problems. So one of the problems that we typically find is as we go faster, and particularly if you try and squeeze a footprint, that where a problem happens, it happens really quick. Whereas if you have one grader doing 20 lugs a minute, you know, you've got 3 seconds between every board before a problem happens. But if you have 2 graders doing 40 lugs a minute, you've got, I think, 1.5 seconds before the next lug. So it gets, as you go faster, problems happen quicker, and typically you don't get a 1-to-1 increase in grader efficiency because they have to look out for issues that do crop up, unfortunately, because it's lumber. So that's all grading systems, and I apologize, it's pretty dry, but basically, no matter how you want to grade, we and other great companies, and I'm trying not to do this as a sales pitch, it's a habit, I apologize. Basically, there's a lot of different options for fitting a grading system that can either run your trimmer and your tally system, or can run your tally sorting system and grading and give you better reporting and perhaps better control. So one of the things that I struggle with on startups is we get customers that are used to pull chains with a grade mark crayon on them, that the grader has to do most of the work. They're determining that the board makes the grade. They're determining that the board is going to go into, you know, they've got to know what they're selling. So if they're looking for specific widths and things of that nature, they need to make sure that they highlight that on the pull chain if they're doing anything of that nature. They may have a customer that wants only a certain amount of brown wood in it, for example, or sap, sorry. So what you end up with is graders typically grading differently depending on the markets. And my assumption, and I haven't done any studies on this, is that the more you change how a grader grades, the less reliable they're going to grade. Because if Monday they're grading one way and Tuesday they're looking at the same board and grading it differently, it's got to be challenging. And I have no ability to grade, so I'm just in awe of how quickly everybody in the industry can do it. But when you put automation in, you then gain automatic length measurement, you gain width measurement that can be accurate up to 40 thou, definitely more accurate than a 1/8 inch grade stick, which comes into how you want to tally it. And, you know, do you round the width, do you round the footage, do you round the surface measure, and every single person does it differently. So when you put a modern sorting system in, or tally, virtual bin sorter, any kind of automation, you then allow the grader to just focus on whether or not a board will make the grade. So for instance, if you have a clear board, and my numbers are typically wrong on this, but let's say you have a clear board that's 6 inches wide and 7 feet long, if it's perfectly clear both sides, well, he can mark an FAS grade on it, but I don't believe it makes FAS, and I'm ignoring walnut in this example because I understand it's different. But if it doesn't make FAS and you have it go to a pull chain with nothing in the middle, typically that could get pulled into your FAS pack and tallied, or have to maybe, if it gets caught, pulled out of the pack and redone, Whereas when a sorter system sees that, it can recognize that an FAS grade of those dimensions is a select, or maybe it's a one common. So you can make it easier on the grader because they're not trying to make that decision on borderline board widths and things of that nature for how they grade by automating it and letting the computer do that, because computers are really easy for measuring and they can handle percentages, and they can, if you have some customers that want to get 10 and wider sorts, typically on a dry line. So if you've got a 10 and wider sort and they only buy 30% of your lumber that you can produce in 10 and wider, but your other customer wants random width, if you take all your 10 and wider out until you've filled the load for that customer, the other customer is probably going to reject your lumber because they've got no 10 and wider in most of their packs. Whereas a good modern sorting system can take 1 in 4 boards, 1 in 5 boards, put them to that 10 and wider pack, and let the other boards go to the random width pack. And it can do it by color, it can do it by grade and color and things of that nature. So once again, you're taking the load of, or the requirement of running your sales out of your grader's hands and putting it into mill management or line manager's hands. Could be the same person in many cases, but basically allow the computer to take care of producing the lumber the way you want in a package and let the grader make a grade. So there's not a study on that, but typically when I've spoke to graders, they find that more handy, that if they grade the same Monday, Tuesday, Wednesday, Thursday, Friday, they're less likely to make errors, you're less likely to have claims, things of that nature. So now we're into optimization. I'm going to start with geometric, and this is really what I'd say is the more common thing now we get asked about is optimizers with graders. 5 or 6 years ago, and I know Bob's got more history with the trimmer optimizer than I ever will, but there's trimmer optimizers were pretty rare, and even the trimmer optimizer sales guys would say they don't do anything a grader can't do, and a grader can make everything there. And I've been in meetings with optimizer salespeople where they've said that an optimizer does nothing but trims back lumber and makes it different. But that's kind of one way of thinking about optimization. The way we found, and our customers working with us have found, is that geometric optimization is a grader assist. Just like I mentioned that marking an FAS board on a board that doesn't dimensionally make it, the same thing is true with regards to wane in the sawmill or even wane in the dry mill. When you have the optimizer and you tell it that it's an FAS capable board because you don't see any defects, or you have properly graded it and it's an FAS board, but it knows that, and when I say no defects, I mean non-geometric defects, because the optimizer is going to be able to see every ounce of wane, provided the bark's not there. I've had that question asked. It doesn't see the wane under the bark. It only sees what's presented geometrically to it. So basically, you grade the board for defects effectively, and I'm grossly simplifying it. As I said, I'm not a grader. And then the optimizer scans it extremely accurately and is going to make, number one, the better fence decision to make the prettiest board it can make. And number two, it's going to be able to take that information, if you give it grade zone information, and determine if it's better as a one common with the wane allowances on it, or if it's better as an FAS for value. So it can make a big difference, and it just takes one more element out of the grader's hands. So we've got a customer that has a single station grading zone, and their comment to me was, we allowed for a system that would handle it if the optimizer went down, the line would still run. And their comment was that you couldn't produce to the same element if you're without the optimizer. It just was such an assist for the grader because they didn't have to think about trimming decisions, that they just wouldn't be able to produce the same amount with just a length scanner. So you can still feed it the information about grade zones along the length, and it gives really accurate scan data. It's an excellent quality control tool. If you start seeing a increase of cutting or anything of that nature, or trim backs, it's going to be coming from something in your process that's not accurate. If you're, purchasing lumber, you could be getting thick and thin lumber, and the optimizer is going to see that. If you're selling dry lumber and you've had thick and thin lumber, it is technically a claimable item, I understand. I'm not totally, once again, I'm not a grader, but you want to make sure that you have the correct thickness along the length of the board so that you don't end up with a rejected load. And their scan data is phenomenal these days. So this is some images of raw scan data, and I apologize. That's all I was able to dig up that really showed the capacity, but these images are filtered. So the one image in the top left over here is, I'm not sure how to, I hit the wrong button. So I don't even know how to move back. Sorry. All right, so there we go. So the one image in the top left is from the inside of a board, and we filtered the data that comes out of modern scanner heads to only display dots every 100 thou. So it can literally pick up data more accurate than every 1/4 inch along the length of the board, and along the width of the board, it depends on speed, but it can pick it up about 2,000 to 3,000 times a second. So you're going to get really accurate width, really accurate length, really accurate thickness. And as you can see in these two images, it can see the wane quite well and knows exactly to the fraction of an inch where it is. So it used to be, when I first started in sales, that it was talking about the modeling, because the big differentiator between optimizer companies was how well they modeled it. And one of my favorite sales guys used to talk about that, particularly on like carriage optimizers, that even though everybody used the same scan head, you had to make up for the data you didn't know, and that's where your modeling technology and how you knew that not every log was round and things of that nature made a very real difference on your recovery on the face of the board, or on the face of the log in that case. And it was the same thing on an edger and a trimmer, because you would typically have 3 or even 6 inch spacing on your scanner profiles, and you'd have to model your wane along that length, and it's not an issue anymore. So I included this to show the amount of, just the massive amount of detail that's possible to get with modern geometric optimization. So then, to highlight it in case that wasn't clear, we were testing an optimizer here, and I scanned myself. So these images, which I think are, I've got a picture of a boot because everybody knows what boot treads look like. And, as we scanned at about 175 feet a minute, running a log conveyor, that's what the scan data looks like. And it's a little blurry, unfortunately, in my screen. I dropped the resolution down, but basically the scan data that you get in modern scanners is far better than a grader can see. We believe that looking at a board from the end, a grader can only see accurately to about 3 or 4 inches in length, unless you give them guides and things of that nature. But the exact positioning of a defect on a board from the far end, they're not going to be more accurate than 3 or 4 inches typically. So whereas an optimizer is going to be to a fraction of an inch. So apologize, I'm running low on time here. That's about what I was worried about. I apologize. So grade optimization. So this is really where technology's at today. And as a matter of fact, we just started up, to my knowledge, the first dry hardwood auto grading system on a rough mill that I'm aware of in the world. But it's got issues like every new technology. So depending on your species, you may need different options. So the first one is you can just go geometric and color vision. And so that's going to give you the 3D scan and a picture. Then you have color vision and what they call grain mapping, which is actually a tracheid scan, and I'll go into a little detail on that. And then another option is to go, is to go with geometric, color vision, tracheid, which is the grain mapping, and an X-ray. And hardwoods in particular is where things like X-ray and tracheid become extremely important, because most of our defects are not clear to see. We can't, we get red oak gets purple stain on it. We get sawing deviations, things of that nature. Walnuts knots are impossible to see. We did a test on walnut boards, and to discover all the knots, I literally had a grader doing this on the board from this distance, and we then sent that board in, and I said, "There's no way anybody's going to see that. You can't scratch a board from 3 inches in an optimizer," and that's where things like X-ray can come in. So the one big advantage that I see, and I'll talk about it a little bit more, is the defect location versus what we can see or input into a geometric grader. The downside in dry hardwoods in particular is what happens when you get a false positive defect. So I've got some examples. So this is tracheid scanning. So everybody knows how, let me phrase that. Geometric is a laser line or laser dots projected and then measured, basically, and it's done so with a camera. But then you add color vision, so you get a color photo, and typically you have lights, and you have to keep the enclosure clean and dust-free, and you got to blow it out more, because if you get dust on the cameras, now all of a sudden you're not seeing the resolution of the board to the accuracy you're looking for. So they use the camera to see things like knots and rot and color variations, which is one of the challenges that hardwood presents, because we get natural color variations that are not necessarily a defect or, a grade effect. And sometimes they are a grade effect. So that's where optimization comes in, and you'll hear a lot of talk about optimizer companies, how they're using AI. AI is the biggest buzzword. I think every single one of them talks about how great they are because they use AI or neural networks and things of that nature. And it's definitely true. AI helps grade optimization learn what is and is not a defect from training it. And it solves the programming conundrum of every new defect needs to be reprogrammed. So, but before you get to that point, you have to scan it. And if you can't see it, you can't grade for it. And the human eye is extremely good at discerning the difference between grease and the knot and various things. Just it's amazing how difficult it is to recreate in a computer. So this is tracheid scanning. And what tracheid scanning is, you can see that it applies a laser line on an oblique angle. So we have in the top right photo, we have a vertical laser line that would be your geometric scan typically. And then we have an oblique angle where it's shining dots, and you can see in the photo below it, the effect on that. It's shining dots so that they illuminate the tracheid cells in the wood, and the cell will basically glow, and how it elongates the circle and shapes and turns it is what's measured. So basically it looks at that dot with a highly accurate camera, sees how much it elongated and how it's shifted, and you can see in the photo on the right that then allows it to go around and see where a defect like a knot is because of the orientation of the tracheid patterns. But you can also see above that things like Douglas fir and softwoods have a much better effect on illuminating the tracheid cells. And I apologize if I'm a little off on that. I'm an arts major, not a scientist, and then you see oak, it shows up as a round dot. So while grain mapping is another tool that they can use, depending on species, and I think this is unfair that it highlights it as oak, but depending on species, you can either get great defect detection because of tracheid, which is grain mapping, or it's not effective. So for instance, I know walnut is a species that the tracheid cells don't illuminate, and it's probably because the walnut is so dark that it doesn't glow. But that's conjecture. So On the left, I've got a photo of USNR Bioluma from a marketing campaign, and that's what's running the dry grading line. So I just thought it's interesting because it shows the inside of the scanner head and the light bars that you have to keep clean. And yes, it's a pine. Both of these are related to softwood boards, and I apologize, but I think we're all used to the fact that most companies ignore the hardwood market in most of their marketing. But you can see there that it's got the tracheid scanning dots on the board, and it's on an angle so that it's getting the illumination, and it's showing that it's highlighting the knots and wane and color stain and things of that nature. And then if you go to the right side, you can see a Lucidine Microtech, and recently Lucidine and was bought out by Microtech, and they're representing Microtech, who's another hardwood grade optimizer. They're the guys, I believe, that do the GoldenEye in the secondary manufacturing. So a bunch of people have seen Wood Eyes and GoldenEyes, and they continue to improve. And the advantage of those lineal scanning, and I'm sorry, I've focused almost entirely on transverse scanning. You can do grade optimization scanning the board lengthways, or you can do grade optimization scanning the board transversely. Now, as far as value savings, you would think that lineally would be significantly cheaper, and it does have some price differences, but it's harder to feed a board and track the piece. It's a solved problem, but it's, you know, it's like a 90-degree. It's another opportunity for a problem. And if you're using X-ray, I think that's where the most significant cost savings between lineal and transverse comes in, is you have less X-ray heads on a lineal scan than you do on a transverse. But effectively, for most systems that aren't using X-ray, transverse and lineal cost about the same. And piece rate wise, they're very similar in their limitations, which is upwards of about 100 boards a minute for hardwood, typically. Maybe 80 at the low end. So the Lucidine Microtech photo, you can see what the color image shows on the board, and that shows a bunch of blue stain, I believe it is. And then the photo below it is the same board scanned with tracheid, and you can see that because of the stain and the nature that the stain is actually a defect in the cell, it doesn't necessarily show, it's showing knots and defects are very hard to discern the difference between them. But then their T3, which is their X-ray to my knowledge, and I'm not an expert, shows very clearly where just the knots are, and has gotten past the surface presentation and the grain mapping issues. And so depending on the species that you need to grade or auto grade, that's one thing you may need to consider and look at, because what you don't want to get in hardwood in particular is false positive grades or false positive defects, because it brings your grade down and or increases your trim loss. So this is a video of auto grading in action on a dry line. So this is running red oak, and you can see it's actually pretty fast. I think they're running about 85 lugs a minute, not 100% lug fill, but it just kind of highlights it. And I have a still shot that I want to show going on later. Now, the reason there's two shots here is because this system was set up to scan and then have a grade mark regrade for teaching the system. So typically it shows, I can't remember if the left is, well, the left is the original scan and the right is the re-optimized scan. So I talked about optimization being a grader assist, and we're talking about grade automation. And the dream of putting in a green line a auto grader and just trimming the boards without a grader running is very close for a lot of people in the hardwood business. And there are a couple of systems that are out there that are doing it. Depending on species limitation, they tend to be better the more you tend towards a lower grade product. And in green, if you get to grade the majority of your lumber again, they may be a very real option, particularly if it's a new mill design. The downside of grade optimization is it takes 8 or 10 lug spaces to come up with a solution. So most systems cannot just change out a 3D geometric grading system and put in a grade optimizer right in there, because by the time it's made a decision, it's already trimmed the board in many cases. So your footprint is still an issue for grade optimization. Same issue was the case in softwood, and they've progressively reduced it. The other thing that tends to happen is sort of like cell phones. They don't just make the phone work better, they add new features. So as things get faster, they just look at more options and they kind of keep the baseline to something. So I don't know that it'll ever get to within 3 lug spaces, but it's potentially going to happen if enough hardwood people will need it, that it should happen, because we typically don't have the length in front of our trimmer lines and things of that nature on dry lines to install grade optimization. And in the green line, we definitely don't typically have the length in most installations to grade scan. But when you're looking at grade zones, this is, in my mind, where the biggest difference between the precision you get from vision grading to geometric grading with grade input is. So I've sketched up a relatively simple board with some defects on it, and I randomly picked a length and a width, so I don't know that I actually end up making a difference in my example. But if you're looking at this board and you have time, you can, and then let's assume the back side is perfectly clear just for simple, I only drew one side. So if you're feeding a geometric optimizer grade data, in this example, you might feed it that the first 6 inches is what we call fence, which it looks at as wastewood. And then the next 5 feet is an FAS zone. And the next foot is a 1 common zone because of the amount of defect in there. And the rest of it is an FAS. So if you feed that to a geometric optimizer, you may find that you end up with a 6-foot 1 common board and an 8-foot FAS board based on this, because it's going to be looking the amount of acceptable cutting units that it can achieve, and it's just marginally not able to make it in a 14-foot long board. But if you look at it from a vision grader, it knows where the defects are. So in this example, it's going to get sufficient length and cutting units, I think, and I didn't do the math, but it's able to stretch the cuttings out to get you potentially a 14-foot FAS or FAS 1 face board. And I know I drew a lot of wane on that board, but this is where currently there's no productive way to feed the amount of information with regards to where the defect is into a geometric optimizer. And now that what has been discussed and talked about in the industry is if you put a grade optimizer and a vision system in, and it interprets what it thinks are the defects. So you basically, and I'm not naming actual prices, but let's say that a geometric optimizer, is 300,000. A geometric plus vision optimizer is 600,000. Geometric vision, grain mapping, full angle stuff, is $1 million, and I think with an X-ray it's like 1 point something. So, and these are spitballed numbers. So, but they're kind of guidelines. So you can add vision for much less than you can add vision and grain. And even with vision and grain mapping, we already showed that there's certain defects that are going to be missed or misinterpreted. So the only thing that we can kind of intermediate step is if you can highlight defects that are not acceptable. So like that could be done on a large touch screen or things of that nature. To my knowledge, nobody's doing that yet, but that's where we see, we being TS, see the industry kind of middle stepping in hardwood so that you get that advantage. And then when you start to get kind of the next step, you don't even technically need graders looking at the same board. You can have them compare the grade optimization, a large screen image of the board, and things of that nature. You might be able to have your graders work in a nice comfy recliner as opposed to sitting on a line getting slivers in their hands. But I think we're a long way off from that still. So where vision grading gets you is when you get a false positive defect, which I've drawn in red in this example. And in this example, you end up now with 3 cuttings. You don't quite make an FAS, I believe in, well, you probably still do on the 8-footer, but you don't make a single FAS out of this. So you might still end up with the same cut and 2 board that you would have with the geometric, because it's identified this red mark as a defect, and in fact, it's just a smudge. So this is an example of a board that was optimized yesterday, and it's graded it as a 1-face board, and it's red oak, and you can see that it highlights the cuttings, and I think it's really, really impressive what you can see on how it's trying to interpret cutting positions. And so L is for the lower face cuttings and U is for the upper face cuttings. So the upper face cutting is 1 solid rectangle is perfect. Lower face has 4 cuttings. So it's got lower face 1, lower face 2, lower face 3, and lower face 4. So when you look at it, it's a little hard to see because it does highlight where it thinks the defects are. But so I've circled them here for you. So those are 2 legitimate defects it appears that it has found. But it appears as though it's got a false positive. So in this exact board, it's reduced the value of that board, making the assumption that it could have been an FAS by about $2.82. It could have been worth, I think, $14. And I'm spitballing on numbers that people have told me. Could have been worth $14. The way it ended up grading it, it's worth $11.80 or something like that, and it's all because of 1 false defect. So on a dry line, these guys don't typically actually sort FAS separated on this run, so it would have been an FAS 1-face. So for them, this works great. But if you're trying to make that separation, that's that's a lot of money to give away for most people, anyways. So. We're on package makeup. The other half of this conversation, this one actually goes a little faster because I got more into the weeds on grading because there's so many options. So in our minds, the 2 limiting factors on hardwood mill production are grading speed and package makeup. So you can, if you look at pine mills that are doing 300 lugs a minute, they've got auto grading and every board looks the same. And typically those are planer mills and they're, nothing but 2x4s 8 foot long coming out. So it's really easy. You can completely automate how you make a pack of lumber. Hardwood, we get random width boards, we get multiple lengths, we get sweep, we get crook, we get split, all of which we accept. So most customers that come to us about package makeup systems, have a perfect pack. They want square edges on the outside, so no wane. The wane has to be on the inside of the bundle so that it's, not there. They want full length boards on the outside, tight layers, full length tight top with no wane on it. And that's what they need to produce. That's the product that they send overseas. And this is what you get. You get the perfect pack. And it looks like this. It doesn't exist. Sorry, a little humor. I did find a picture of a perfect pack at a trade show once, and I blocked out the vendors' names. And they told me that it took them like a day to assemble that pack with a rip saw just specifically to make the perfect pack for a trade show. So obviously, you don't want to rip all your lumber to make a nice, pretty pack unless you're getting more money than anybody I've heard of for your lumber. And you can't produce enough packs that look like this. So you'll see a lot of people in the industry, and we have great people in this industry talk about how they have to hand pack a pack to make a perfect pack. So I happen to be at a customer site, and I won't say which one, but this is what a hand pack lumber is. And I happen to grab a pack that has some boards that are on end inside the pack, and the edges are at a square and things of that nature. But this is the reality of what is a decent looking pack that people sell. So the goal is not the last photo. In my mind, the goal for automation is to get to this photo so that we can get enough people that we can run our production facilities. So your typical stacker, you've got a guy that's flipping boards. You can see that there's a little shelf above there that he can flip the good boards so he can make a good outside layer, and he can do that. That is usually the production limiter. So this stacker, I think, averages about 3 or 4 layers a minute tops in this example. The mechanical cycle rate on that one is 12. So you can have a guy on the far side to make it a little nicer, clean up anything that happens on the stack. But realistically, the guy's ability to make those tight layers and pretty packs is what limits most hardwood package makeup. So this is a photo that we took this year of a pack of lumber that's come out. Now it's FAS, so it tends to be nicer looking. That's come out of a pack. Now, I'm not an expert. It's pretty close on a standard stacker to what we saw on that example of a hand-piled pack. But you have to take time to do that. So we've created, and so have some other people, auto course makeup systems. And their goal is to measure the boards, make tight layers, put long boards on the outside. We even have one that's scanning for wane and taking the wane off the outside and the top layer. And the advantage of that is you can get upwards of 14 or 15 layers a minute peak by automating it, because now you can see here that, you know, while people still have to touch boards and it's not perfect, you'll see that there's boards with long boards coming in on the outside. It allows that flipping of boards happens by the boards going back around in a circle. You can build 5 or 6 layers at once, so you can kind of cherry pick the boards to make a tight layer. There's a lot of conversation about this, and the footprint though is huge, is the biggest problem. So it doesn't, you know, like the grade optimizer, it doesn't fit in most existing footprints, but it does make an easier job for making packs and allows people to do it. And we've got 2 of these installed, and they both operate in a similar way. Sorry, it's supposed to autoplay. So the first one was a dry pack. This happens to be a green pack of lumber in this video. So, but it happens, it kind of shows. So you can see that we're scanning the boards. We have a long period of time to try and look at each of those boards, and I use the example of like a poker hand. If you put 15 cards face up, you can deal yourself a pretty nice poker hand. If you only put 5, you're going to get what you get. So basically, you're using the space in the trays to cherry pick to make a maximum width, and you can achieve an average gap measured of less than 1/2 inch on a system like this per layer. And why that matters is when you're dry packaging, in particular, a tight layer lays better on the stacker. This video is not playing very well, and I apologize. I have better video of it, but it seems to be killing my PowerPoint. But the advantage of these course makeup systems is instead of having 2 or even 3 package makers or a bunch of guys pulling chains, you now have 2 people that are making packages. You can go through a strapper system, which allows you to squeeze the pack tight, put straps on it. It can handle things that the actual hardest part is a fixed width pack, because when we do like 7-inch wide boards in our hardwood industry, they're from 6.5 to 7.5 inches wide and swept. So if you've got a layer of 6.5 and a layer of 7.5, you could have 6-inch width difference between the 2 layers, so that it's not the same as a plain 2x4. So apologize, I'm going a little quick here. Oh, next. So when you're measuring though, there's another thing that often gets forgotten. So when we're measuring for a board for what its width is, we need its average width. We don't actually typically care about sweep and shape, because we just have to know how wide it is to sort it properly. So these 2 boards that I've got sketched out here are exactly the same width, but they don't take the same space in a layer. So when you're making layers, and with the guy manually making them, he or she are handling this. but it's a lot of work. And then dimensionally, one of the things that any course makeup system has to handle is whether or not the boards nest, if they're swept, how wide what we call an effective width they are, in addition to their length. And if you have edge quality or even grade quality, that additional information. So you've got to mix all these up and make a perfect layer that'll stack nice and make as nice of a pack as possible. And you can see here the gaps in that example. We go off of effective width. So even though there's gaps inside between the boards, those gaps exist. And we can calculate nesting if we have enough sensors reasonably well, and account for the fact that two boards beside each other create half as much gap as a single board beside two straight boards. So package makeup it's all about if you can find enough pieces to deal yourself the perfect hand, and then deal yourself the perfect hand on the next one to make a nice layer. And then when you make that nice layer, your stacker has to be capable, or package maker, sorry, has to be capable of laying that layer properly. And it's actually easier on like one common packs than it is on FAS, because you tend to have more narrow pieces. So if you have like a 10 and wider pack, it's really hard to fill a 4-inch gap with a 10 and wider pack. So different packs will have different limitations on how you set up your system to run. And there are other systems that do that, and they're not all as large as those. Both those systems that we showed there were designed to have 7 layers, and because it's not well known what's needed yet. So if you're building it and you have 7 layers and you can run the same production with 5, you're okay. If you're building it with 5 and you need 7 to get your production, you're not okay. So we've kind of gotten to the point where 5 layers seems to be sufficient for most requirements. And you can even do less. There's systems that have 3 or 4, but it depends on how close to that perfect pack you're trying to make. So what the future holds in my mind is robotics. Because while lumber handling equipment is really efficient at handling things at high speed, and this is fairly low speed when you actually look at it, it's possible now with robotics to cost effectively pick up boards and make layers. Now you'll notice that they're using vacuum heads in this. So the downside of a vacuum head system, I think I can replay that. Downside of a vacuum head system is you can't pull the layer tight. They look pretty good on here, but this happens to be a pine mill, so all their boards are the same width. They're just trying to pick grading, so they don't have to worry about mixing lengths and mixing widths and all that cherry picking. But that's something that's totally possible to do in hardwood, because we don't have every layer the same width. We feel that you'd still need to put that onto a package maker so that you end up with a straight side pack as opposed to narrow and wide layers. Because even with course makeup, you're going to have some gap, and you still want that nice straight side for both stability and presentation. So, sorry. And finally, that's all I've got. So I'll stop sharing and yield the floor. Thank you.
So let's go ahead, and we've got a little bit of time here if you can spare some, but we'll open up the meeting to any questions for Riley. No questions? Which that was a lot of information, Riley, and you know, the robotic stacker was, that kind of took me by surprise, because that's one of those things that we've talked about actually within our company. But when you look at that, you know, if everything was the same width, same length, no problem. But because it's random width, random length, that just presents a different problem. But anyway, Riley, thank you very much for sharing some great information with us. If anyone thinks of any questions later on, please feel free to reach out to Riley. I hope everyone has a great rest of the week, and take care and stay safe. Okay. Thanks. Talk to you later.
Appreciate it, guys. Thank you.
Thanks, Riley. Thank you.
Thanks. Bye.